We are used to seeing the sun here on Earth as a small ball of light moving through the sky, peaking at midday and setting again over the horizon. But the view of the sun from space is a very different picture indeed. This is what the sun really looks like. It's a huge burning ball of gas more than 330 times more massive than the Earth. Fueling this raging furnace is a process called nuclear fusion in the core of the sun. This burns hydrogen into helium, and one of the byproducts of this reaction is an almost massless particle called a neutrino. Neutrinos do not like to react with anything, and so pass right through all the layers of the sun and out into space at very, very near the speed of light. Let's hop on one of these neutrinos and travel with it towards the Earth. Hold on tight, here we go! Whoa, there goes Mercury. And Venus. And as a dot in the distance getting bigger is that place we call home, the Earth. And that's taken just a few seconds, but in reality the journey would have taken a little over 8 minutes. We do know quite a lot about how the sun works, and we can calculate how many neutrinos should be arriving at the Earth every second. You need a lot of fingers to count them all though, as it's 7 with 10 zeros after it, passing through every square centimetre. Now I've already said that neutrinos don't like to interact with anything. This makes them very, very difficult to detect. However, scientists have found a way. They fill huge rooms like the one you can see here with water. When the neutrinos interact with the water, they create something called Cherenkov radiation, which is kind of like an optical sonic boom. And this is detected by over 11,000 little photomultiplier tubes, which you can see on the walls and ceiling of this detector, called the Super Kamio Candy, or Super K for short. It's in Japan. Super K is actually a kilometre underground and filled with 50,000 tonnes of water. But as happens a lot of the time in science, things were not quite right. The detectors were only detecting about a third of the amount of neutrinos that the calculations had predicted. Now this was a very, very big problem, because if the calculations were wrong, then it might mean that the sun's furnace was slowing down. This would mean that the sun would die a lot sooner than expected, causing those of us still on Earth to get more than just a little hot under the collar. Fortunately, the problem was solved, and the sun was burning at the rate originally predicted. This is very, very good news for us, because it means the sun should carry on shining for around 5 billion years. The problem was solved because it was realised that there are actually 3 types, or flavours, of neutrinos called electron, muon and tauon. The neutrinos change flavour during their journey from the sun, and the original experiments could only detect the electron flavour. Okay, time is almost up, but we'll have to leave you with this cool fact. Imagine that every neutrino reaching the Earth were actually a person. If that were true, then 25 times more than the population of the whole Earth would be passing through your thumbnail every second. Now that's fun. That's all for today. Until next time, remember, science is fun.